We are going to look at two examples where we are going to revolve a region about the y-axis, and we're going to use disks and washers. We're going to find the volume of the solid obtained by rotating the region bounded by the given curves about the y-axis. In our first example, we are given a curve, two lines, and a region. I went ahead and graphed these, and you can see that the region that's enclosed by all of these curves is this region right here. When we revolve this region about the y-axis, the first thing that we need to do is find the radius. That radius is this length right here, and our radius is just equal to x. Our volume is pi times the integral from c to d of r squared, which is x squared times dy. We have a dy because we're revolving about the y-axis, and the width of each circular disk is equal to dy. Our volume is then pi times the integral from c to d. C is equal to 0 and d is equal to 4. So we have 0 to 4. Our x squared is equal to y. Let me highlight that. That's right up here. So we just have y dy. This gives us pi times y squared over 2 from 0 to 4. This is pi times 16 divided by 2 minus 0, and we get an answer of 8 times pi. This example that we just did is an example where our region was lying right against the y-axis. In our second example, we have a region where there is a gap between our region and the y-axis. We have two curves, x is equal to y squared, and x is equal to 2y. The region that is enclosed between these two curves is this region right here. And we're going to revolve this region about the y-axis. Because we're revolving a region about the y-axis, we are going to integrate with respect to y, and we'll want to begin by finding our intersection points, and we want the y value for those points. We're going to find that by setting our two curves that we're given equal to each other. This gives us y squared is equal to 2y. Let's pull the 2y to the left, and we can factor out a y. And this gives us that y is equal to 0 and y is equal to 2. Let's highlight that because we'll need that in a minute. Because there is a gap between our region and our axis of rotation, we are going to have an outer radius and an inner radius. Our outer radius right here is given as x is equal to 2y, and then our inner radius right here is given as x is equal to y squared. Let's now write down our formula. Our formula is v is equal to pi times the integral from c to d, our outer radius squared, which is x out squared, minus our inner radius squared, x in squared, times dy. Let's go up here and let's label this as x out, and we'll label this one as x sub n. Now let's go ahead and put this into our integral. This is pi, the integral from 0 to 2. Our outer radius, which is the quantity 2y squared, minus our inner radius, which is y squared squared. And we have dy. Let's simplify this before we integrate it. We have the integral from 0 to 2. This is 4y squared minus y to the fourth times dy. This now, if we integrate it, is 4y cubed over 3 minus y to the fifth over 5 from 0 to 2. This gives us pi times 4/3. 2 cubed is 8, so we multiply that by 8, and then minus 2 to the fifth, that is 32, and we divide that by 5, and then we subtract off 0. To make this easier, let's pull out the 32, so we have 32 pi, and then we have 1/3 minus 1/5. If we get a common denominator of 15, this is going to be 5 minus 3 over 15. So 32 times 2 is 64, and this gives us 64 pi divided by 15. And there's our volume. Often, when you do volumes of revolution, your answers don't come out super nice.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.